just a second. I will share my screen. I believe you can see my presentation, yeah? Can you see my presentation?
We do.
Yeah.
Great. Dear colleagues, I'm glad to present you overview consolidating refugee data with an interactive dashboard for monitoring Ukrainian migration. This work is done under the joint project of National Aerospace University Kharkiv Aviation Institute and Max Planck Institute for Demographic Research. So the Russian full-scale invasion of Ukraine in 2022 led to one of the fastest and biggest population displacement in recent history. Millions of innocent Ukrainians have been uprooted from their homes and indeed scattered as far afield as neighboring countries. The resulting mass migration has presented significant social, economic, and humanitarian challenge in Ukraine and the countries taking them in. Exploring the drivers, scale, and consequences of this displacement is critical to informing policy, resource allocation, and safeguarding those effects. However, despite the attention to the crisis has received from all around the globe, integrated tool for looking into comprehensive and real-time data on the movements of refugees and needs remain absent. Various international organizations, governmental agencies, and non-governmental organizations have been collecting data on the movement of Ukrainian refugees. These data sets include statistics on the number of refugees entering different countries, demographic breakdowns, and information on displaced populations, specific needs and vulnerabilities. However, this data is often dispersed across multiple platforms and presented in static formats, making it difficult for policymakers, humanitarian actors, and researchers to access, analyze, and utilize cohesively. The fragmentation of data sources creates challenges in understanding the full scope of the crisis and hampers the ability to respond effectively. So this study addresses these limitations by developing an interactive dashboard that consolidates data from multiple sources into a user-friendly platform. And this dashboard will visualize the migration flows of refugees from Ukraine, providing real-time updates and detailed insights into the demographics, destinations, and evolving needs of displaced individuals. And by integrating data from national immigration services, international organizations, and non-governmental organizations, the dashboard offers a comprehensive view of the crisis. And in this context, the development of the interactive dashboard represents a critical step towards enhancing the global response to the Ukrainian refugee crisis. By providing a centralized platform for migration data, the study aims to improve data transparency, support evidence-based decision-making, and contribute to the overall resilience and recovery of the displaced Ukrainian population. The international response to this refugee crisis has been robust, led by frameworks such as Humanitarian Response Plan and the Regional Refugee Response Plan. These plans focus on providing essential services to internally displaced people within Ukraine and refugees in neighboring countries. The efforts have ranged from emergency cash assistance and non-food items to health services, shelter support, and educational initiatives for displaced children. And for instance, the International Organization for Migration has played a critical role in coordinating cross-border relief efforts, providing health services, shelter, mental health support, and livelihood assistance to millions of displaced individuals within Ukraine and in neighboring countries. However, the lack of centralized and accessible data on the movement and needs of Ukrainian refugees and internally displaced people present a significant challenge to effective humanitarian response. Data on population displacement is collected by different organizations, including governmental organizations, United Nations High Commissioner for Refugees, and NGOs, but it's often fragmented. across multiple platforms. So this creates difficulties for stakeholders attempting to develop cohesive strategies and allocate resources effectively. To address this gap, the present study aims to develop an interactive dashboard that consolidates data on Ukrainian refugees from diverse sources into a single accessible platform. By visualizing the scale and patterns of displacement, the dashboard will provide real-time insights into the evolving crisis, helping humanitarian actors, governments, and international organizations better respond to the needs of displaced population. So the system adopts a modular three-tier architecture comprising the data, application, logic, and presentation layers. Each layer is developed to handle specific functions, ensuring flexibility, performance, and ease of maintenance. The data layer manages the collection and storage of migration data from various sources, such as United Nations Human Rights Commission, the International Organization of Migration, and National Migration Authorities. The system regularly fetches data from these sources via APIs and formats it into the unified JSON structure. So JSON was chosen for its lightweight nature, facilitating fast data processing and transmission over the web. Once collected data is stored in a centralized relational database system with PostgreSQL as a database of choice, and the entity relationship diagram, which is shown on the slide, is designed to support secure refugees for refugee regions and country period. The system also allows efficient storage and travel storage data sets, ensuring stability as the system expands to more regions and periods. So the core functionality of the dashboard can handle by the application logic layer, which processes the raw data, performs necessary computations, and manages user interactions. This layer is implemented using Node.js on the server side, which facilitates the creation of a lightweight, event-driven architecture capable of handling asynchronous data requests. The presentation layer is built with modern web technologies to provide users with an interactive and responsive user experience. The front end of the dashboard is developed using HTML5, CSS3, JavaScript, script libraries such as Bit3, JS, and Shell.js deployed for rendering visual elements of the dashboard. The core component of the front end is an interactive map hero. Built using scalable graphics technology. This allows for smooth integration into the zoom in training and the clicking on individual countries to reveal detailed migration statistics. One of the dashboard's primary features is its ability to display real-time migration data. The system relies on asynchronous calls via HTTP to retrieve and display updated information from external sources without requiring full-page reloads, ensuring that the users always have access to the most current data. And user can filter data by date, country, and type of migration, for example, internal displacement or cross-border movement. Additionally, the dashboard includes certain options to allow users to rank countries by refugee inflows, population density, and other key metrics. Given the system's nature, which processes large data sets from various sources and renders complex visualizations, performance challenge is inherent. Therefore, the system implements multiple strategies to enhance performance, reduce latency, and improve user experience. One of the main performance optimizations involves asynchronous data loading through the Fetch API. This allows the system to fetch migration data from multiple sources in the background without blocking the user interface. As the data is loaded asynchronously, users can continue interacting with the dashboard without experiencing delays or page reloads. And this also supports the real-time nature of the application, as the Fetch API updates the data dynamically when new information becomes available. By implementing lazy loading, the system only retrieves and processes required data at a particular moment, reducing the initial load time. For example, detailed statistics or visualizations for specific countries are only fetched with when the user selects the country rather than loading all data upfront. This reduces strain on both the client side and server side processes. The system uses caching mechanisms to store frequently accessed data to optimize performance. Redis, a high-performance in-memory key-value store, is used to cache migration data users, such as total number of refugees or popular migration routes commonly requested. By caching this data, the system can serve it directly from memory, reducing the need to query the database and lowering server load repeatedly. Additionally, the caching mechanism is configured to update only when new data becomes available, ensuring that users consistently access the latest information while minimizing redundant requests to external APIs or databases. So data aggregation techniques applied to reduce the size of the data set before rendering them. For example, instead of processing daily refugee data, the system may aggregate the data for months or quarter, depending on the user's selected time frame. And this reduces the amount of data that needs to be processed and visualized at any given time. On the front end, performance optimization ensures visual elements such as the interactive map and charts render quickly and smoothly. The interactive map built using SVG is designed to be lightweight and scalable. SVG is optimized for performance, allowing for quick rendering and scaling without sacrificing detail, even when zooming in or panning across the map. One of the most notable achievements of the dashboard is the ability to integrate disparate data sets from various international organizations and national migration authorities. By offering real-time updates, it allows for timely monitoring of migration flows, helping stakeholders better understand the dynamic nature of the refugee crisis. The system's architecture, which relies on asynchronous data fetch and caching and scalable backend, ensures the data is current and accessible. This is particularly important for humanitarian operations, where timely information is critical for resource reallocation and intervention planning. However, despite this strength, there are some limitations to consider. The area for potential improvement is the dashboard's handling of demographic data. While the system provides some information on refugee demographics, there is room to expand this feature to offer more detailed insights into specific vulnerable populations, such as children or individuals with disabilities. And providing such granular data could enhance the dashboard's utility for specialized humanitarian operations, focusing on protection services. Also, the dashboard's current geographic coverage is primarily focused on European countries, which reflect the primary destinations for Ukrainian refugees, and expanding the dashboard to include migration data from other regions and tracking internal displacement within Ukraine would provide a more comprehensive view of the crisis, and this would be particularly beneficial for stakeholders involved in Ukraine's broader humanitarian and recovery efforts. So the novelty of the dashboards lies in its ability to collect, process, and visualize migration data dynamically, combining real-time updates with advanced filtering options. Integrating multiple data sets into a single platform gives users a holistic view on the ongoing refugee crisis caused by Russian full-scale invasion of Ukraine. The system scalability, supported by modern web technologies and backend architecture, ensures that it can adapt the future expansions and be applied to different migration contexts globally. This capability is particularly relevant for future humanitarian crises or scenarios where population displacement requires continuous monitoring. Another thing I need to mention is that it's the first step of the comprehensive information system, which will include the simulation of migration flows and also interactive analysis of factors that impacted the dynamics. So thank you for your attention, and I'm ready to answer the questions.
Thank you, Dmitry. It was very interesting. Questions, dear colleagues? You have some time. Hanna, please.
Dear Dmitry, thank you for your presentation. I would like to ask, maybe I did not catch this information, is your dashboard is open source or not?
It will be open source, so now it's MVP, and we are working on some additional modules for simulation, so for forecasting and for analysis of different factors that are influencing the migration flows. And after that, it will be open, and we will share the code also as an open source platform.
Thank you.
Is it under some project support, maybe? Yes.
Yes, we have joined project with Max Planck Institute for Demographic Research in Germany. Yeah, and this work is under that project.
And maybe another question. Do you have some insights on the basis of this information, which is not very obvious from...
So the most obvious insight that like we should put all our efforts to finish the wars with Ukrainian victory, and that will stop all the refugee flows.
Yeah, and another question, maybe more technical. How often, as I understood, you automatically update the data set, yes? And how often?
Yeah, daily.
Daily, okay.
Yeah.
Maybe you plan to forecast something in the future on the basis of the data.
Yeah, that's the plan. So the plan is the forecasting of flows to different countries, but also, which is, in my opinion, more important for Ukraine is forecasting and finding out which factors are influencing the migration flow back to Ukraine. Yeah, because it's important for policy making and for government decision making.
Yeah, maybe it's the most important forecasting.
Yeah.
Yeah, and maybe a very short technical. What is this technology stack here?
So we used JavaScript for front end, different libraries. Also, we used Fetch API for collecting the data. Yeah, and now we are using Python for simulation. So we need to connect all of that.
What is the hosting?
So now it's internal, and we host it internally. But after we'll finish with MVP, we'll publish it. But I believe it will be Max Planck servers. Like Max Planck Institute has a chain, and they have like very powerful servers and dashboards like that, and like data like that they store in their internal servers and publish it openly.
Okay, thank you very much. It was very interesting.
Thank you.
Yeah, thank you.
Thank you.
The next presentation